Our next topic up that we need to cover is a preliminary topic that's going to get us ready for doing things with complex numbers and with quadratic equations, and that topic is square roots. We're talking about anything that has a radical. When I talk about a radical, I'm talking about this symbol right here, the square root symbol, the classic square root symbol. So in general, if b squared is a, then b is a square root of a. We can look at the examples that we have here. 5 squared is 25, and that means that 5 is the square root of 25. In the same way, 10 squared is 100, and that means that 10 is the square root of 100. You do have this button on your calculator, the square root button. On the TI-30, it just looks like that with a parentheses. So what you do is you type that, type your parentheses, whatever you need to take the square root of, close your parentheses, and then hit enter. The parts of a square root are the radical sign. If you hear me say the word radical, that's that symbol right there. The radicand is what's inside, and a radical expression is the entire thing. If you have a negative in front of a square root, all that does is change it into a negative number in the end. That's a negative square root. So even if you typed it in your calculator that way, it would tell you the correct answer. Negative square root, parentheses, 25. Close your parentheses, hit enter. It's going to give you negative 5. The same way with negative square root of 100, it's going to give you negative 10. It's a negative square root. It's doing the square root process first, and then it's tacking on that negative in the end. Whenever you see a square root problem, the first thing you should try to do is type it in your calculator, because if you could type it in your calculator, that's going to save you a lot of work in the long run. Let's do these in the calculator. And then on the next page, I'm going to show you how to evaluate them if there is no calculator. So this one, again, in your calculator, you hit square root button, type the number 81, close your parentheses, and the calculator should give you 9. Go through and type these in your calculator and make sure that you can get the correct answers. This should give you negative 3. This one, you would type square root, parentheses. It's going to give you that first parentheses. You do 1/25, same thing as 1 divided by 25. Close your parentheses and hit enter, and your answer should be 1/5. Here, your answer should be 10. You just don't close your parentheses till you get after the 64. On this one, you got to be careful to close your parentheses after the 36. Start a new square root. It opens parentheses. Close your parentheses after the 64. When you type it in, you should get, again, a 10. No, that's not right. That would be 6 plus 8 would be 14. So notice the square root being over the whole thing is very different from the square root being over the different pieces. All right, if we have ones like this, we cannot type them in the calculator. So if you type the square root of 500 in your calculator, you will not get a nice number. You'll get a big decimal. Or if you have one with variables, you can't type it in your calculator because it'll give you decimals. You can't even type an x in your calculator. Here's how you're going to simplify a square root if you can't type it in your calculator. What you're going to do is you're going to break it into all of its prime factors using a factor tree. So for example, on the square root of 500, I know 500 is divisible by 5 and 100, right? 5 times 100 is 500. 5 is prime. I can't break it down any further, so I circled it. 100, I can divide it into 5 and 20. Can't break the 5 down any further. 20 is 2 and 10. 10 is 2 and 5. And once you get down to the end and you can't break it down any further, you have all of your prime factors. You want to list those prime factors out in numerical order. So the factors that I have are 2, 2, 5, 5, 5. And the best way that I have to describe this next portion is you're using the buddy system just like you would in Boy Scouts or Girl Scouts or, you know, summer camp or anything. If you have a buddy, you get to go outside. If you don't have a buddy, you don't get to go outside. I'm talking about pairs here, specifically pairs of 2 because we have a square root. So anything that has a pair or a group of 2 can go outside. This guy has a pair. This guy has a pair. To be a pair, they have to be the same exact thing. And notice I didn't group all 3 of those 5. I'm talking pairs of 2. All right, just like I said, the buddies get to go outside. That means the 2, this group, and the 5 gets to go outside. When you set things out, if you have more than one thing or more than one thing inside, you multiply them. So 2 times 5 would be a 10 outside. This 5 right here does not have a buddy, so it has to stay inside. If you have separate square roots like we have here, before you even start the problem, as long as there's no negative signs inside those square roots, you can just multiply the square roots together. So the square root of 6x times the square root of 3x is the same thing as the square root of 18x squared. You can take note of this up here, that rule. If you have two square roots multiplied by each other, you can multiply the things inside as long as it's not negative things inside of those. Now we can use the same process to break this one down. Square root of 18x squared, that's 2 and 9. 9 is 3 and 3. And we know x squared is the same as x and x. So writing out our factors in numerical order again is 2, 3, 3, x, x. Looking for buddies, the 2 does not have a buddy. We know he's going to end up inside because he doesn't have a buddy. The 3's and the x's have a buddy, so outside we'll have 3x. Inside we'll still have a 2. That is the simplified version of each of those radicals. Take a second, pause your video, and see if you can do these two on the bottom. As soon as you unpause, I'm going to be talking about those two. The square root of 75, when you break it down by the factor tree, it looks like this, 5, 3, and 5. If you put those in order, it would be 3, 5, 5. The 5's will get grouped together. So the 5's are buddies, they get to go outside, and the 3 has to stay inside. The square root of 5x times square root of 10x is the same as square root of 50x squared. The 50 will break down into 2, 5, and 5. When you put those in order, 2, 5, 5, and you can't forget your x's here. There's 2 of those. X and x makes x squared. The 5's have buddies. The x's have buddies. The 2 does not. So 5 and x gets to go outside. They have buddies. 2 has to stay inside. All right, the same rule with multiplication. Division works the same exact way. And we can look at, again, if you could put it in your calculator, absolutely do. If you don't get to crazy decimal, then your calculator will give you the right answer. This one you can actually type in your calculator. The 25 over 16, you type square root 25 / 16, close your parentheses, and that's going to give you something like 1.2. You use the button math, or you use the second F-D. It's F arrow D. And that will change it from a decimal into a fraction or vice versa. And so whenever I type this in, I get 1.2. Whenever I use this button right here, I get 5 over 4. A lot of times on Alex or on Pearson, it's going to tell you to write your answer without a decimal, or it's going to tell you to write it as a simplified fraction. Look at this rule here. What we can do, if we have 2 square roots, we can just go ahead and do that division. Again, as long as there's not negative signs in there, and as long as the bottom is not 0, we can go ahead and do that division. That's what I want to do on this right side. So the square root on top, square root on bottom, what I can do is divide those pieces before I even start. 150 divided by 2 is 75. X cubed divided by x is x squared. When you divide variables, you subtract the exponents. And then we can break it down just like we have been. 75 is 5 and 15. 15 is 3 and 5. Put them in numerical order, so 3, 5, and 5. We still have our x squared, which is x and x. Pair of 5's, pair of x's will give you 5x square root of 3. Adding and subtracting square roots works the same way as adding and subtracting variables. They have to be like terms. So you have to have the same exact thing inside those square roots to be able to add, and you're not going to add the exponents or anything inside. You're just adding the coefficients. So 7 square root of 11 plus 6 square root of 11 is the same as 13 square root of 11. The same way as 7x plus 6x would be 13x. We're just treating them like terms. If you have one, like this one letter A down here, that needs to be broken down, you can break it down before you try and add them. So take a second, see if you can break that 12 down, and then we'll finish the problem together. The 12 will break down into 2, 2, and 3. So 7 square root of 3 plus, we have buddies, right? 2, 2, and 3. The 2's are buddies. So we'll have 2 square root of 3. The 2's get to go outside. The 3 has to stay inside. They are like terms because they have the same thing inside the square root. So now we can just add the coefficients. 7 and 2 makes 9 square root of 3. Do the same exact thing on the next. Try and break it down with a factor tree. Pause now and try and do that. The 50x will break down into 2, 5, 5, and x. The square root of 32 will break down into 2, 2, 2, 2, 2, and x. If you write those out in numerical order, The 4 that's already with the problem is just going to stay with it, right? That's 4 times square root of 50x. So that's going to be 4 times 5 square root of 2x. I'll underline to show you where that came from. This right here gave us that after we used the factor tree. The same way here, this minus 6 has to stay with the problem. And then the 2, 2, 2, 2, 2, and x will simplify into 4 square root of 2x. Again, I can say that this part that's underlined matches up with that part that's underlined. Now we can combine, we can multiply those, and then combine like terms. That would be 20 square root of 2x minus 24 square root of 2x. And 20 minus 24, these are like terms now. 20 minus 24 is negative 4 square root of 2x. Take a second again, pause, see if you can figure out the answers here. On the first one, 8 plus 9, they have the same like terms, gives you 17 square root of 3. On the right, 1 square root of 17 minus 20 square root of 17, they are like terms. 1 minus 20 is negative 19 square root of 17x. Nothing inside the radical changes. Oh, we just did this problem, didn't we? 7 square root of 12. Perfect. 7 square root of 3 plus square root of 12. I'll show you these answers anyways, so that breaks down. We have 7 square root of 3 plus 2 square root of 3 makes 9 square root of 3. Same thing over here, we can break these down. You've already seen this problem. 4 times 5 square root of 2x minus 6 times 4 square root of 2x. 4 times 5 makes 20, 6 times 4 makes 24. 20 minus 24 makes negative 4. Pause and try and do these on your own. The 27 and 12 break down as such. That gives you 5 times 3 square root of 3. Again, the blue matches with the blue. 2 square root of 3 matches up with that lighter color. 5 times 3 makes 15 square root of 3. 15 plus 2 makes 17 square root of 3. Very similar problem on the left. Here's how your factor tree breaks down. Here's what happens when we match the blue with the blue, the light color with the light color. Notice the x stays in there. It doesn't have a buddy. I didn't have it listed down here, but the x would be listed there as well. 6 times 3 is 18. Negative 4 times 2 is negative 8. And since they're like terms, 18 minus 8 gives you 10 square root of 2x. All right, the last big piece is rationalizing denominators. So if you type this in your calculator and you type this in your calculator, you would get the same exact value. They're the same exact thing. In math, we prefer to not have a square root on the bottom of a fraction. There's a way to solve that. So if I have a square root on the bottom of a fraction, the way I'm going to fix that is by multiplying by that square root on the top and bottom. We've talked about before, if I had something like 2 over 2x, I can divide those away. Really what I'm doing here is I'm not changing the value of my 1 over square root of 3. The square root of 3 over 3, this is the same thing as 1 over 1, right? So I didn't change the value of it. What I'm doing is I'm just finding a nifty way to write it in a new way. So 1 times square root of 3 on top would be square root of 3. Square root of 3 times square root of 3 on the bottom would be square root of 9. And then if you type this in your calculator, square root of 3 over 3. Anytime you have a square root in the bottom, if it's just a single square root, you can multiply by that square root on the top and bottom to clear the square roots off the bottom. Again, this is just a thing in math. We don't like to leave square roots on the bottom. Here's a couple of examples. Let's see if we can do these together. That first one, 15 over the square root of 6. Since the square root of 6 is what's on the bottom, we don't want to leave a square root in the bottom. You can multiply by the square root of 6 on top and bottom. You get 15 square root of 6 over square root of 36. If you type this in the calculator, 15 square root of 6 over 6. And then if you can simplify your fraction, you do want to do it. So in this case, we're ignoring this, right, because it's locked up inside that square root. But the 15 and the 6 on the bottom, the 15 here and the 6 here, they do have something in common. You can divide them both by 3, and if you do that, divide 15 by 3, you get 5. Divide 6 by 3, you get 2. And that's the most simple answer we can get there. We rationalized the denominator. Notice that what we started with had a square root in the bottom. What we end with does not have a square root in the bottom. That was our goal. All right, on the next one, it might help to notice first that we can actually break down that square root of 8. We can actually simplify it before we even start. So 8 is 2 and 4. 4 is 2 and 2. We end up with buddies that can go outside. So this is the same thing as 12 over 2 square root of 2. Now to rationalize, what we can do is multiply by the square root on top and bottom. Whenever we do that, we get 12 square root of 2 over 2 square root of 4. 12 square root of 2 over 2 times 2, right? Because the square root of 4 is equal to 2. So that's 12 square root of 2 over 4. And again, if we can simplify the fraction and divide by the same thing on top and bottom, we want to. We can divide both of those by 4. 12 divided by 4 is 3. And 4 divided by 4 is just 1. And so we don't have to write the 1 in the denominator. Our final answer is just 3 square root of 2. So I think everybody would agree that this simplified down much better with no square root at the bottom, right? And that is it. That's the bread and butter of this lesson.